Hello, geometry students. Today we're beginning a new unit. We're going to spend several days looking at areas of particular types of polygons. Some of the ones that we have seen before, a little bit will be review. We'll be seeing some new formulas for some polygons that you haven't ever seen before, and we will continue deeper discussion of what we called composite polygons and how to go about finding their areas. Okay, so our upcoming unit is all about discovering areas and sometimes some perimeters of various polygons. Please copy down your title, area of triangles and quadrilaterals. Our objective for today is to recall the formulas and skills necessary to find the areas of triangles and quadrilaterals. Now the verb I put in this one is to recall these formulas because most of the stuff that we're going to be seeing today is old material that you did back in junior high. So a lot of these formulas are not going to be new to you. We may have one or two that might be new to some of you, but most of this will be review. Let's get started. Okay, first and foremost, we've done a little bit of area work, but not much. So let's make sure we have at least a reasonable working definition for what area means. And my highly technical definition for area is the amount of stuff required to fill a two-dimensional object. Now why do I put amount of stuff? Well, the stuff can be different things. Those are typically the measurements, the feet, the inches, meters, pink flamingos, whatever it is. That is the amount of stuff required to fill a two-dimensional object. Well, the first formula that we're going to take a look at is for our friend, the three-sided polygon, the triangle. We have looked at this formula briefly already this year. We needed it while we were doing the composite shape segment in a circle. So review. The area of a triangle is found by multiplying 1/2 times its base times its height. Now, one of the messages you're going to hear repetitively throughout this unit is the terms base and height. These are easily confused when it comes down to geometry. Now in geometry, the word base does not have anything to do with being on a shape's bottom, and height does not have anything to do with measuring straight up and down. So the connection that you need to be able to make is that base and height are always perpendicular to each other in a diagram. So it does not matter that B is on the bottom. It does not matter that H is going up and down. It matters that they are perpendicular to each other. They can be anywhere in the problem as long as they're perpendicular to each other. So let's take a look at this formula in action. Here we have a formula or a problem. We are told to find the area of the following triangle. So anytime we have a problem, if we have a formula, our first step ought to be to write the formula down. So we have a triangle. We're looking for area, and the area of a triangle is found by 1/2 times the base times the height. So what we want to do is we want to plug in the values. Don't automatically assume that the only values in the problem are automatically the base and the height. Remember that base and height are always going to be perpendicular to each other in a geometric figure. So we look in the problem, we see where we have perpendicular line segments, and it just so happens that it is the 6 and the 4. So we plug the 6 and the 4. It does not matter which one you call the base and which one you call the height, because 6 times 4 is the same as 4 times 6. 4 times 6 is 24, and half of that is 12. There you go, 12. And we are talking about meters squared because, again, an area measurement is second dimension. Area has length and width at the same time. Moving on. Now we're going to take a look at the different quadrilaterals that we've discussed in recent months. We're going to start off with our friend, the parallelogram. Now this is a formula you should also be familiar with. The area of a parallelogram is found by multiplying its base times its height. Now, once again, the way that you discover the positioning of base and height in a parallelogram is they will always be perpendicular to each other. The common trap that students want to fall into with a parallelogram is they typically want to call one side of the parallelogram the base, and then they want to call the other side of the parallelogram the height. And that is not the way it works in most parallelograms. Okay, so find your base and your height. Okay, they will be perpendicular to each other. All right, so let's take a look at an example. Find the area of the following parallelogram. This is a typical type problem. They will provide various measurements inside of the figure, and they will make you select or solve for the appropriate measurements. As always, anytime we have a formula, we want to write down the formula before we begin solving anything. Okay, so we go, okay, it is a parallelogram. It is an area question. So we go, cool, we have a formula for that. Area equals base times height. Now we just need to make sure that we get the correct information to plug in for the base and the height. Remember that base and height in geometry are always perpendicular to each other. Okay, so do we have a measurement where it's perpendicular? Okay, yeah, we do. We do have some perpendicular stuff going on in there, and we do have the overall measurements for both of those particular locations in the graph, 10 and 7, and obviously 10 times 7 is 70. The units of measure this time are millimeters, so we have 70 square millimeters. All right, a rhombus. Okay, rhombus is another type of parallelogram, and that's an important piece of information to remember. A rhombus is a type of parallelogram. Okay, well, the formula for finding the area of a parallelogram is area equals base times height. So since it is a parallelogram, it will follow the same formula. Let's take a look at an example. Find the area of the following rhombus. Once again, okay, we have a formula for it. Anytime we have a formula for a particular shape, we always want to write down the formula before plugging anything into it. So area of a rhombus is base times height. We need to plug in the information. Once again, base and height are perpendicular to each other. Don't fall into the trap of thinking that base and height are always two of the sides, because that is often not the case. So it is not 9 times 9, okay? It is 9 times 7. Okay, that 7 is what is perpendicular to our side lengths. So 9 times 7 is obviously 63. Once again, the units of measure were millimeters, so it is 63 square millimeters. This is going to sound real familiar again. Look at our friend the rectangle. Once again, a rectangle is a type of parallelogram. Since it is a type of parallelogram, it ought to follow the same formula as a parallelogram. The area of a parallelogram is found by base times height. The only difference is with a rectangle, the base and the height are the side lengths of the rectangle. And we should know that because the side lengths of a rectangle are perpendicular to each other. So when we say base and height are perpendicular, we ought to be able just to pull side lengths straight off of the rectangle and plug them into the formula. So let's take a look at that. Find the area of the following rectangle. As always, if we have a formula to go along with a problem, we're going to write our formula down. Area equals base times height, because a rectangle is a type of parallelogram. Formula is base times height. And with a rectangle, since the sides are perpendicular to each other, all we have to do is pick the opposing side measurements, 3.5 and 1.5. We're going to multiply those together, and we end up with a decimal point. Okay, it's very, very possible that area can be decimal points. It's just a number. There's no reason to freak out about it. It's just a number. Write it down. 5.25. The units of measure were inches, so it's going to be square inches. There's one more type of parallelogram that is out there, and it is our friend the square. Okay. Well, once again, square is a type of parallelogram, so the formula ought to remain the same. Area equals base times height. However, square has an interesting property going on with him. He is a rectangle, which means his side lengths are perpendicular to each other. But square is also a rhombus, which means his sides are congruent to each other. So when it comes time for us to multiply the opposing side lengths together, what we find out is it's the exact same measurement twice. So a more convenient and often used formula for a square is to say the area of a square is found by taking one of its side lengths and squaring it side times side. Let's take a look at an example of a square. Very easy, nothing to it. Find the area of the following square. Well, as always, if we have a formula, we're going to write it down. Area equals side squared. So all we have to do is determine what is a side length of the square, or possibly solve for a side length of the square if it's unknown. In this case, we have it 7 squared, and 7 squared is 49. The units of measure were centimeters, so it is 49 square centimeters. Okay, enough of the parallelograms. Okay, here's a formula that we probably ought to be familiar with as well. It is for our friend the trapezoid. Now remember, a trapezoid is a four-sided figure that only has one set of parallel sides. Its area is found by multiplying 1/2 times the sum of its bases times its height. Now, a couple of things to keep in mind with this formula. Okay, you have to add the bases together, so you better know which sides the bases are. Now, do not fall into the trap of always thinking that base means bottom, because in geometry it does not mean bottom. Okay, with a trapezoid, the bases are the two sides that are parallel to each other. If they happen to be on the top and bottom, then they are on the top and the bottom. If they happen to be left and right, then they're on the left and right. They could be diagonal. They could be doing just about anything. As long as they are the two sides that are parallel, then those are the two sides that are the bases. Now, as always, the height is going to run perpendicular to the bases. In this case, that means the height is moving up and down between the bases. But of course, if the bases are side to side, on the left and the right, that means the height would run sideways in between them. Okay. But anyway, we have a formula. Should be a formula that you have seen before. So let's see it work in a problem. Okay, trapezoids are a fairly popular question for area questions to show up on, because there are a lot of different measurements that are easily available inside of a trapezoid. So there's a lot of opportunities for people that don't know which sides are which to pick on the wrong values to plug in their formula. Anyway, just like every other problem, if we have a formula to accompany a problem, we will write our formula down. It is a trapezoid, so we'll write down the area is 1/2 times the sum of the bases times the height. Okay, so the next thing we need to do is we need to get our values plugged in correctly. All right, so let's see if we can't figure these values out. We're going to need to know the lengths of both of the bases, and we're going to need to know the height, which is the guy that is perpendicular between the bases. Okay, so the bases are the two sides that are parallel to each other. Okay, so in this case, it is the guy that is on top and the guy that is on the bottom. So we have the 20 and the 26. So we do have both of the bases. We're going to plug those in for B1 and B2. It does not matter which is which. Okay, so plug them in either order. We also need to know the height, which is perpendicular to both of the bases. And you can see that we have that measurement in there as well. It is 8 meters. Okay, so we have everything we need. We plug the values in. Okay, now please remember your order of operations. Okay, please excuse my dear Aunt Sally. Parentheses must be dealt with before multiplication. So inside of these parentheses, where those bases are being added together, we need to add that together first. If you do not handle that addition first inside of those parentheses, you will miss the problem. Okay, so 20 plus 26 would be 46. Now it is a tie for order of operations. It is all multiplication going across there. So 46 times 8, I believe that is 368, and half of that would be 184. Okay, the units of measure are meters, so 184 square meters. Now, the last type of shape for us to look at is the kite, and this is probably the one that would be, if you are unfamiliar with just one of these shapes, kite is probably the one. Okay, so let's take a look. There is a special rule that kites fall into. Okay, actually a special category that they kind of fall into. Okay, if you have a quadrilateral that happens to have diagonals that are perpendicular to each other, then the area can be found by a fairly specific formula. Now, strangely enough, this formula does not show up in most textbooks, okay, and I'll show you what textbooks want you to do with a kite later on, okay, but here is the formula that most textbooks do not reveal. The area of a kite can be found by multiplying 1/2 times the lengths of its two diagonals. Okay, and this formula is not just for a kite, as I said, it is a formula for any quadrilateral that has its diagonals perpendicular to each other. So this formula would apply not just for a kite, but also for a rhombus and also for a square. Now, if you're thinking, well, we already have formulas for squares and rhombi, okay, why would we need another formula for it? Well, you'd be surprised. Sometimes uh, the type of information that they give you about a rhombus or the type of information they give you about a square, it might be more convenient to use this formula. Okay, so the area of a quadrilateral with perpendicular diagonals can also be found by adding the four areas of the right triangles that build that quadrilateral. This is the alternative way that I mentioned a moment ago. Most textbooks don't want you to use this diagonal formula. They want you to find the four areas of the four triangles that construct the quadrilateral and then add them all up. Okay, and that certainly is an option. However, I think that the diagonal formula is much more convenient. Press pause if you need more time to copy this one down. I'm about to turn the page and move on to the example. Okay, so here is a kite, okay, and we're told to find the area. As always, anytime we have a formula, we're going to record that formula and then plug in the necessary information. So I'm going to start off with this, the diagonal formula that I like, 1/2 times diagonal 1 times diagonal 2. Now, it does not matter which diagonal is which, okay? We just need the two overall lengths. Okay. Now, as you can look in the picture, you can see, of course, that the diagonals are intersecting each other. They chop each other into pieces. And the overall length of one of the diagonals is 4 plus 4, and the length of the other is 1 plus 10. Okay, so obviously we have an 11, and we have an 8. Okay. Well, 8 times 11 is 88, and half of that is 44. The units of measure were feet, so it's 44 square feet. Now that's very easy. Okay, very simple calculation, just a new formula. Now, while we're on the topic, let me go ahead and show you what the textbooks would prefer that you do. Okay, the textbook would prefer that you take the kite and think of it instead as 4 right triangles. Okay, but in all reality, it's not really 4 right triangles. It is 2 triangles. There are 2 different triangles in a kite because a kite has symmetry coming through its middle. You can tell that you have 2 larger triangles that are going to be congruent and then 2 smaller triangles that are going to be congruent. Okay, now you need the exact same information to work these problems or these formulas as you did to work the diagonals formulas. Okay, so this again, it's kind of curious that they want you to go through the long way on this. Okay, but the 2 different triangles that are there, we have one of them that has a base and a height of 1 and 4, and we have another one that has a base and a height of 4 and 10. Well, on this left-hand calculation, 1 times 4 is 4, and half of that is going to be 2. On the right-hand calculation, 4 times 10 is 40, and half of that is going to be 20. Okay, so very easy to get those areas, but of course keep in mind that was only 2 of the triangles, and there are 2 each of these triangles, pardon me. Okay, so we're going to take that 2 on the left, we're going to double it, we're going to take that 20 on the right, and we're going to double it, so that's a 4 and a 40. And when you combine all of the areas, all 4 triangles added together there, 4 and 40 is, once again, 44 square feet, which is the same calculation that we got on the previous page. Okay, so if you'll just take a little bit of time and memorize a new formula, you will find that you can save yourself a lot of trouble on kites and sometimes with rhombuses and squares. That's the end of the notes. I appreciate you finding time to get your notes taken care of. I will see you in class.